Stephen Hawking, the man who turned a wheelchair and a robotic voice into the loudest megaphone for the universe. He was the rock star of science, the closest thing physics ever had to a Marvel superhero, except his superpower was explaining black holes in plain English. But here's the twist. Many of the cosmic truths Hawking wished to prove, he never lived to see. They remained puzzles, unsolved equations scribbled on the chalkboard of history. Take Hawking radiation, his 1974 prediction that black holes slowly leak energy until they vanish. Nature, Vol. 248, 1974. Brilliant, revolutionary, but still not directly observed. Or the dream of uniting Einstein's relativity with quantum mechanics, the so-called theory of everything, which he called the Holy Grail of physics. A Brief History of Time, 1988. And Hawking wasn't just about equations. He warned that humanity must colonize other planets if we are to survive. BBC Reith Lectures 2016. He even joined projects like Breakthrough, Listen to Search for Alien Life, SETI Institute 2015. Today on Infinitia Verity, we'll dive into 28 breathtaking ideas Hawking hoped would be proven true. Some might reshape our universe, others might save our species, so buckle up because, as Hawking said in 2018, remember to look up at the stars and not down at your feet. And today we'll do just that. To understand what Stephen Hawking was chasing, you need to picture the world he lived in. The year is 1963. Hawking is just 21, a promising Cambridge student, and suddenly diagnosed with motor neuron disease. Doctors gave him 2 years to live. Hawking, My Brief History, 2013. But instead of surrendering, he chose to outthink the universe itself. Science at that time was like a family feud. On one side, you had Einstein's general relativity, explaining planets, galaxies, and gravity on the grand scale. On the other, quantum mechanics, the bizarre world of subatomic particles. Both were brilliant, but like oil and water, they refused to mix. As Hawking once joked, physics was like two angry parents who won't speak to each other. A Brief History of Time, 1988. Meanwhile, humanity was standing on a cosmic cliff. The Cold War was stockpiling nuclear weapons, space agencies were racing to the moon, and computers were just learning to think. Hawking saw all of this, the promise and the peril, and realized science wasn't just about curiosity, it was about survival. And survival, for Hawking, was personal. Confined to a wheelchair, losing his voice, he became the symbol of mind over matter. As Kip Thorne, fellow physicist, said, Stephen turned his disabilities into his strengths, focusing his entire being on the problems of the universe. Thorne, Black Holes and Time Warps, 1994. So when Hawking asked big questions about black holes, aliens, or the future of humanity, he wasn't doing abstract math. He was fighting against time, both his own and ours. All right, time to crack open Hawking's unfinished homework. Here are the cosmic puzzles he desperately wanted to solve but never got to finish. And we'll start at the center of his universe, black holes. Hawking's biggest mic drop moment came in 1974. He predicted that black holes aren't eternal monsters. They actually leak tiny particles of energy until they evaporate. Nature, Vol. 248, 1974. Imagine the Death Star slowly hissing air until it vanishes like a balloon. Problem? No telescope has ever caught a black hole in the act. He knew the math was right, but the universe still owes him the proof. Physics has one golden rule: information can't be destroyed. Burn a book and in theory the ash and smoke still carry its info. But Hawking realized if black holes evaporate, all the info inside disappears. Poof, gone. That broke physics in half. For decades, Hawking wrestled with this. In 2004, he admitted he might have been wrong and conceded a famous bet to John Preskill, and Thorne, Caltech, 2004. But the paradox, still unsolved. Hawking loved bold names. The cosmic censorship conjecture basically says the universe hides its ugliest secrets. Singularities, those infinite density points, should always be tucked behind an event horizon, like cosmic nudity laws. He wanted to prove this, but never could. Even today, physicists debate whether the universe sometimes lets the singularities peek out. Hawking often joked that if time travel were real, we'd already be flooded with tourists from the future. Hawking, The Universe in a Nutshell, 2001. But in theory, wormholes could allow it. He actually threw a time travelers party in 2009, sent invitations after the event. Nobody showed up, which to Hawking was hilarious proof we're not there yet. In his final paper, Journal of High Energy Physics, 2018, Hawking argued that our universe might be just one bubble in a vast cosmic foam. Different bubbles, different laws of physics. Imagine each universe as its own Netflix show. Some boring, some cancelled early, and maybe one where pineapple pizza doesn't exist. Hawking never saw evidence, but he wanted this cosmic Netflix confirmed. Hawking, with James Hartle, proposed the no-boundary idea that before the Big Bang, time itself curved smoothly, like the North Pole has no edge. Hartle and Hawking, Physical Review D, 1983. But proving it? Impossible, at least so far. Did time really begin 13.8 billion years ago, or is there a before? Hawking left us dangling. Einstein died chasing it. Hawking carried the torch. A grand unified theory would stitch together the strong, weak, and electromagnetic forces into one neat equation. He joked that finding it would let humanity know the mind of God, A Brief History of Time, 1988, but he knew the equation stayed just out of reach, like the ultimate cosmic crossword puzzle. Black holes weren't Hawking's only obsession. He also wanted to solve the biggest mysteries of the cosmos itself. These were the questions that kept him staring at the ceiling of his Cambridge office, long after everyone else had gone home. Okay, the grand unified theory was only step one. Hawking wanted to go further, merging that with gravity to create the ultimate theory of everything. It would unify the four fundamental forces into a single, elegant framework. Hawking, The Nature of Space and Time, 1996. Think of it like stitching together a patchwork quilt of physics into one seamless blanket. Spoiler, we still don't have the blanket, just a pile of fabric. Hawking believed that most of the universe is invisible stuff we can't see, dark matter. He compared it to an invisible scaffolding holding galaxies together. Hawking, Brief Answers to the Big Questions, 2018. Physicists have built detectors underground waiting for a particle to show up. So far, nada. The universe is still ghosting us. Even stranger than dark matter, dark energy, the force making the universe expand faster and faster. Hawking called it one of the greatest puzzles of modern science. Reith Lectures, BBC, 2016. Is it a property of space, a new field, a cosmic prank? We still don't know. But if Hawking had cracked it, he'd have explained not just the past of the universe, but its ultimate fate. Will the cosmos end in a slow freeze, a catastrophic crunch, or a violent rip-apart of space-time? Hawking studied these models for decades. Hawking and Ellis, The Large-Scale Structure of Space-Time, 1973. But he left no final answer. The universe keeps its death date a secret. Here's the big fight in physics. How does gravity work when things get really small? Hawking pushed models of quantum gravity, but no one has cracked it. String theory, loop quantum gravity, holographic universes, all attempts to do what Hawking wanted, make gravity obey the quantum rules. Hawking, The Universe in a Nutshell, 2001. Right now it's like trying to teach an elephant ballet. Remember Stranger Things and the Upside Down? Hawking was fascinated by the possibility that more dimensions exist beyond our 3 of space and 1 of time. String theory suggests there could be 10 or even 11 dimensions. Polchinski, String Theory, 1998. Hawking wanted proof, but so far we're stuck in 3D. No portals, no upside down, just Netflix. Hawking strongly believed life must exist elsewhere. He even worked with Yuri Milner on the Breakthrough Listen project to scan the skies, SETI Institute, 2015. But he also warned, if aliens are advanced, meeting them could be like Columbus meeting Native Americans, not great for the locals. Hawking, Into the Universe, Discovery Channel, 2010. Proof of aliens, still missing. But Hawking would have celebrated even a single microbe on Mars. So far, we've seen Hawking wrestle with invisible matter, hidden dimensions, and the possibility of neighbors in the cosmos. Next, we'll dive into the future of humanity AI, space colonization, and survival itself. For Hawking, these weren't just theories, they were warnings. Hawking didn't just stare at equations. He worried about humanity's future. He warned us that science wasn't just curiosity, it was survival. And here are the ideas he hoped would come true before it was too late. Hawking kept circling back to the mystery of dark energy. If we could explain it, maybe we could predict or even influence the fate of the universe. Reith Lectures, BBC 2016. Imagine if dark energy could be harnessed. Infinite power. Of course, right now, we can't even define it. It's like trying to fight a ghost with a dictionary. Hawking believed microbes almost certainly exist elsewhere, but intelligent aliens? That was the big question. He compared a potential first contact to Columbus landing in America, disastrous for the weaker side. Into the Universe with Stephen Hawking, Discovery Channel 2010. He wanted proof, one way or the other, and yet radio silence, the cosmic phone still isn't ringing. Hawking feared AI could outsmart humanity. In 2014, he warned that AI might spell the end of the human race if not controlled. BBC interview 2014. But he also wished to see if machines could achieve true consciousness. Could they think, feel, even dream? As of now, we have smart algorithms, but no robot Shakespeare. Hawking urged that humanity must become a multi-planetary species. He predicted that within 100 years we must colonize Mars if we hope to survive. Hawking. Brief Answers to the Big Questions, 2018. Elon Musk loved that idea. NASA's working on it too, but so far Mars is still a dusty, empty Airbnb with no tenants. Hawking thought even Mars wasn't enough. Long-term survival meant reaching other star systems. He championed projects like Breakthrough Starshot, using lasers to push tiny probes toward Alpha Centauri. Breakthrough Initiatives, 2016. It sounded crazy, but so did airplanes once. Hawking didn't just want probes out there. He dreamed of humans leaving the solar system. Warp drives, wormholes, or generation ships, he didn't care how. He just wanted proof it could be done. Hawking, The Universe in a Nutshell, 2001. We're nowhere near. The farthest a human has gone is the Moon, 384,000 kilometers. Alpha Centauri, 40 trillion kilometers. Yeah, long commute. More than anything, Hawking wanted proof that humanity wouldn't destroy itself. Nuclear war, climate change, pandemics, he warned about them all. Brief Answers to the Big Questions, 2018. He hoped science cooperation and maybe a second planet would keep us alive, but he knew survival wasn't guaranteed. His dream was to see humanity pass the test of its own intelligence. These weren't just scientific theories. For Hawking, they were lifeboats' blueprints for humanity's survival in a dangerous universe. But Hawking's imagination didn't stop at survival. He also wondered about the strangest, most speculative frontiers of reality itself. Hawking wasn't afraid of the weird questions. In fact, he loved them. Here are the final 7 frontiers he hoped humanity would one day solve. Hawking and James Hartle proposed the no-boundary model. The universe could be finite, but with no edges, like the surface of a sphere. Hartle-Hawking model, 1983. He wanted proof. Is the universe truly endless, or does it have a cosmic fence? To this day, the jury's out. Hawking wrestled with the paradox of whether information is lost in black holes. This led him toward the holographic principle, the idea that our 3D reality may be encoded on a 2D surface. The information paradox. Hawking, 1976-2004 debates. If true, we're all living in cosmic holograms. Keanu Reeves would approve. Hawking sometimes entertained the possibility that reality itself might be a simulation. He never endorsed it strongly, but he understood why it fascinated philosophers and scientists. Is reality an illusion? Public Lectures, 2015. He wished to know, are we players in a cosmic video game, or is this the one true reality? Why does time only move forward? Hawking studied thermodynamics and entropy, proposing that disorder gives time its direction. Hawking, A Brief History of Time, 1988. But he wanted a definitive answer. Is time's arrow fundamental, or just an illusion? Hawking first argued that black holes destroy information. Later, he admitted he might have been wrong, conceding a famous bet in 2004, Hawking vs. Pre-Skill, 1997-2004. He wanted to settle it once and for all. Is information eternal, or can the universe delete files forever? Hawking accepted his body was failing, but he dreamed of consciousness living beyond biology, maybe through uploading the mind or preserving knowledge forever. Brief Answers to the Big Questions, 2018. He didn't fear death. He feared that human understanding would be lost. In the end, everything circled back to one dream, a single equation that unites relativity, quantum mechanics, and cosmology. The theory of everything. Hawking, various works, 1980s-2018. It was his lifelong quest. He never found it, but he hoped someone someday would. Because to Hawking, the universe wasn't just a place we live in, it was a puzzle we were born to solve. Stephen Hawking left us with more questions than answers, but maybe that's the point. Maybe his greatest gift wasn't proving everything true, but daring us to keep asking. As Hawking once said, "My goal is simple. It is a complete understanding of the universe, why it is as it is, and why it exists at all." And that remains humanity's unfinished business. When Stephen Hawking passed away in 2018, the universe didn't suddenly make sense, but his questions kept echoing. Physicists are still chasing his black hole paradox in massive particle colliders and simulations. Nature 2019, Science 2021. Cosmologists still debate whether the universe had a boundary or infinite beginnings, and tech leaders quote Hawking's warnings about AI and climate as if they were roadmaps for survival. Even pop culture carries his legacy. From The Simpsons to the theory of everything, Hawking became the face of curiosity itself, proof that the human mind can travel farther than the body ever could. So what's the aftermath? It's that billions of people who will never solve an equation still dare to look at the night sky and ask the biggest questions. Hawking didn't give us all the answers, but he gave us permission to keep looking. And so, 28 facts later, we're left with irony. Stephen Hawking, the man who decoded black holes, never cracked the universe's final riddle. But maybe that's the point. Answers end the story. Questions keep it alive. Hawking's real legacy wasn't proving everything true. It was teaching us that even in a wheelchair with time against you, you can still chase infinity. So, next time you look at the night sky, don't just see stars. See questions waiting for you.